Good afternoon, students. Today, the 26th day of January, Republic Day. We are going to deliver a lesson on thermodynamics. This is very important chapter, I suppose. Nearly 10% weightage is given on this chapter. That means 2 to 3 questions is expected in the year 2025 NEET. So be mindful to this subject. Thermodynamics. Okay. Thermodynamics. Thermodynamics. What is the meaning of this? Therm means heat. Dynamics means motion. While heat is in motion, actually it is thermodynamics. Okay? But we should know what is thermodynamical equilibrium. What is thermodynamics? Therm means heat. And we all know heat is an energy, sort of energy. And dynamics means motion. Where heat is in motion. How it is done? You all know, if I draw a diagram like this, it is clear to you that the water level, if there is a difference in water level, okay, then it is independent of the content of the water, but it depends upon the level of water. So water will start flowing from this to this tube. The area of cross section of this tube is more than this one. If it is alpha, it is beta. Then it is clear that alpha is greater than beta. So how long the water will flow from the tube alpha to tube with cross section beta? So long they are not on the same level. Okay? Like heat. Heat actually flows from a body where the temperature is more than that of a body where the temperature is less. And this is the rule regarding flow of heat. And flow of heat means flow of heat energy. Am I clear? So, you see, if the temperature of this body is T1 and this one is T2, and if it is connected with the end of a diathermy material, then that is conducting material, then heat will flow from this to this one. How long it will flow? If it is T1 and if it is T2, then you can write T1 is greater than T2, it will flow so long the temperature doesn't come, the temperature of both the bodies equal. When the temperature of both the bodies equal, then no heat will flow. And we can say the two bodies are in thermal equilibrium. So this is an empirical idea so far as thermal equilibrium is concerned. And now I will describe you in detail what should be an ideal definition of thermal equilibrium. Okay? Now you see, the case where if I keep certain gas within a closed chamber, if I keep a certain gas within a closed chamber, it may be monatomic, diatomic or triatomic gas, no problem. And this chamber, the outer layer of this chamber is made of a insulated material. It is made of insulated what? Insulated material. Okay, insulated material. And what happens? Neither heat will flow from this chamber to the environment, or it will enter from environment to the chamber, and it is actually called adiabatic chamber. What type of chamber it is? Adiabatic chamber. What type of chamber it is? Adiabatic chamber or isolated chamber. What can I say? Isolated chamber. Isolated. Neither heat will flow from here to the environment. This one is environment, and this is chamber. So what happens? Total heat content, that is Q equals to constant. Q equals to constant. So what happens? Del Q equals to 0. Del Q equals to 0. There is no change of heat. That is del Q equals to 0. So what it is? Actually it is an isolated system, insulated material covered by insulated material, and this is called adiabatic chamber. The adiabatic chamber is that chamber where the heat, there is no exchange of heat. There is no exchange of heat. There is no exchange of heat. No exchange of heat. What should the definition of equilibrium? We deal equilibrium with some certain gas. That is, here the gas we consider as an ideal gas. What type of gas it is? Ideal gas. What type of gas it is? Ideal gas. Ideal gas equation you all know. What is the equation for an ideal gas? Gas equation PV equals to nRT. Okay. For n moles of gas, that is nRT. Am I clear? So you should know what is ideal gas. Ideal gas is that gas where the attraction between two molecules or among molecules is ignored. What we do? There is no attraction among the molecules or with the molecules and the wall of the container. There is no attraction. There is no attraction between molecules and the molecules and the wall of the container. So there is the ideal gas is having no potential energy. Ideal gas is having no potential energy. Okay, clear? Then the condition for equilibrium is that here is the parameter P. What is it is? Pressure. What it is? Pressure. V is volume. N is number of moles. R is universal gas constant. T absolute what it is? Absolute temperature. All these parameters are not are the parameters which are not dependent on each other. This is separate parameter, this is another separate, these all are parameters separate. They are not dependent on each other. There is no correlation among the three, among all the parameters. So the thermal equilibrium state, when the system will reach in thermal equilibrium state, then P, V, N, R, T, all are constants. All are constants. What does it mean? All are constants. Suppose a gas is kept here and this is made of insulated material. Okay. So if the volume is constant, pressure is constant, number of moles is not also entering is constant, R is also universal gas constant is a constant, T temperature is constant, absolute temperature of the gas is constant. So all are constants, and when all are constants, then we can say the gas within the chamber is in equilibrium. What we loosely term? We loosely term that when the temperature of both the bodies are equal, the two bodies are in equilibrium. That is a loose term. Okay? But actual definition is this. So we can write here the number of independent terms in the expression for kinetic energy. The number of independent terms, the number of independent terms in the expression of kinetic energy, in the expression of kinetic energy, do not depend on each other. They do not what? Depend on each other. This is the ideal definition. What number of independent terms? Independent terms means all are such independent terms. In the expression of kinetic energy, what is kinetic energy? What is the expression for kinetic energy? You know. What is the reason behind the development? How we get kinetic energy? Suppose the gas is here, and according to zeroth law, what is zeroth law? Foremost, you should know what is zeroth law. So I have told you thermal equilibrium, and what is zeroth law? That is also very important. Later on, I will describe in details. So I have understood. I think you have understood P, V, and T. This is a gas equation. It is a gas equation for an ideal gas. And another equation is here. What equation it is? P plus A by V square into B minus B equals to RT. You know, it is clear? And another equation is like P plus A N square by V square into V minus NB equals to nRT for n mole of gas. And this is van der Waals equation. What it is? Van der Waals equation. And this equation is the gas equation. What type of gas it is? Real gas. A real gas. In nature, we do not get any gas which is an ideal gas. We can assume certain gases like nitrogen, etc. are nearly what type of gas? Nearly ideal gas. But in nature, in reality, real gas is observed. In real gas, the attraction between molecule is not negligible. You take a note. In real gas, the attraction between molecule or molecules among molecules is not negligible. Also, in real gas, the volume of the container, with reference to the volume of the container, the volume of gas each molecule is not negligible. Okay, so we have to calculate that. We have taken into account. So this is real gas equation and this is ideal gas equation. So what is the difference? The real gas will be converted into ideal gas. Okay, when it will be converted into ideal gas? If the medium is rarer one. If the density of the medium is very low, then what happens? Then the molecule will be at a far apart. Suppose I am here. I am speaking to you when you are hearing me, and if you are listening my voice. But if I go outside the room, my voice will be little faint. And gradually, if we leave this campus, you won't be able to hear my or listen my voice. So distance is a parameter. So the distance is very high with reference to the mass of each molecule, then we can assume that the attraction force between two molecules is not there. So there is no question of potential energy. Okay, clear? This is very important. Mostly people do not know what is potential energy and what is internal energy, what is total energy of a gas, ideal gas. And here also, if the density of gas is very high, then we cannot ignore the molecular assessment or the molecular disposition of the gas or molecular volume of the gas. We cannot ignore it. Here you have considered it, but it is very large. Suppose I am a person standing here now, and with respect to the entire campus of this school, my volume is negligible. But within this room, my volume is not negligible. But if a room is size of the room is very small, then also my volume cannot be ignored. Okay, so my volume is not ignorable with respect to this room size, but it is ignorable with respect to total size of the campus. Similar case is happening here. So try to ponder the phenomenon. Okay, now I will tell you zeroth law. What is zeroth law says? Just you see here a body, you can term the body as A and the another body as B and the third one as C and third one as C. You see that if this body, the temperature of this body is TA, the temperature of the body is TB and the temperature of the third body is TC. And what zeroth law says? If the body A is in equilibrium with B, then temperature TA will be equals to TB. If these two bodies are in equilibrium, then TA will be equals to TB. And if here also these two bodies are in equilibrium, then you can write TA equals to TC. Now you cut off the two bodies, this body from these two bodies. Then what you can write? Then the relation between the temperature relation between the two bodies, like you are giving TB equals to TC. Why? As T equals to TB, T equals to TC, so you can write TB equals to TC. So if two bodies are in thermal equilibrium with the third one, okay, then the two bodies will be in equilibrium with each other. This is actually zeroth law. And what zeroth law says? That all the bodies are in same temperature. So no heat will flow, that is zero heat will flow. That is zeroth law. Am I clear or not? So I suppose you have understood what is zeroth law, what is real gas, what is the difference between real gas and an ideal gas. We all are real human being, and it is not expected that we will be an ideal human being. If you consider the case of Swamiji, he was an ideal human being more or less with reference to us. But in true sense, if you strictly measure all the characteristic features of Swamiji, little bit deviation you will find. So in nature, ideal situation never arises. Okay, am I clear? So this is all about the your thermodynamical ideas. So far I have taught this to you. Now I will tell you what is first law of thermodynamics. What? The first law of thermodynamics. What? The first law of thermodynamics. Now it is also applicable in case of a real gas. In case of real gas. Applicable in case of real gas. You see here, first law of thermodynamics. What? First law of thermodynamics. First law of thermodynamics. What it says? Suppose del Q amount of heat is given to a gas within this chamber. Then what happens? There will be change in internal energy and certain external work done will take place, or it may expand. It may expand. There is possibility of expansion. So heat, if you apply heat, the initial internal energy will be changed and then external work done will be there. And using calculus, we can write dq equals to du plus dw. And what is dw? du equals to p dv. From where we have got this dv? Isn't it? Just consider a cylinder. Consider a cylinder. The volume initial, it is the cross-section area of a cylinder. Okay? And gas is there, and if you apply heat, then the piston will be there, and it will rise certain level where it will come to this level, and the piston will be here. Then there is a change in height due to energy, due to work done, and that is A is the area of cross section of the cylinder, piston. Now what you can write? You can write F dot dx, that is equals to dw. If the dot product between the two, they take place on the same direction, then you can write F dx cos of 0 degree. That is, they are working in the same direction. What? Force and displacement. So you can write F dx. And you all know that if you divide force by its area of cross section, you can get pressure. Okay? The pressure. So force is nothing but equals to cross section area into pressure. So you can write here P into A into dx. What you can write? P into dv. A into dx means the volume of this portion, the volume of this portion, the volume of this portion. So that is dv. So I have written here P dv. So if you apply heat according to first law of thermodynamics, heat will work in two ways, act in two ways. It will, foremost it will increase its kinetic energy, its internal energy, then the residual amount of heat will just do certain external work done. If there is no external work done, when it happens? If you consider a piston, like if a container like this, if V is constant, if you fix the volume of a container as a constant, then what will happen? dV will be 0, then dq will be du. So the amount of heat that you are giving, am I clear or not? The amount of heat that you are giving will be entire heat will be converted into its internal energy. Will be converted into its internal. What internal energy is? This is very important question. They may ask you in NEET. What is internal energy? What is the internal energy? You tell me. Who can tell me what is internal energy? What type of energy it is having? Within these molecules are having certain energy. How we know it is having energy? Because the molecules are in chaotic motion. The molecules are in chaotic motion. So the total energy means total energy of the molecules. That is total energy means mechanical energy. What energy? Mechanical energy equals to kinetic energy plus potential energy. Am I clear? Total energy means kinetic energy plus potential energy. So, what is the internal energy in this case? Why the temperature? You know, if we apply heat, then temperature also will increase, na? So, what is the reason behind the increase in temperature? Why temperature increases? Because increasing temperature means that the collision probability increases. Collision among molecules if increases, then we can say that more temperature means more collision. More temperature means more collision means more kinetic energy. More temperature means more collision means more kinetic energy. More temperature means more collision means more kinetic energy. Okay? Then total energy is equal to these two. Where this potential energy goes? Is there any potential energy? No. Why not? Because this is an ideal gas. In case of ideal gas, the distance, this rarefied gas, the distance between two molecules is so large that we consider, we ignore the attractional force between them. And if there is no attraction, then the question of potential energy doesn't arise. If there is no attractional force, the question of potential energy doesn't arise. Am I clear or not? So you can start off this. So here what you are getting, this is the internal energy is equals to entire internal energy is kinetic energy. Entire internal energy is kinetic energy. No other energy is there. The entire internal energy is kinetic energy. Also, this is kinetic energy is also proportional to heat, temperature. Kinetic energy is also proportional to temperature. Okay. So it is clear that entire internal energy means then you have to write internal energy equals to entire kinetic energy. Why potential energy is not here? Why not here? Because the gas is ideal gas. If you take real gas, then you have to consider potential energy, and the relation will be different, and that will be you may deviate from first law of thermodynamics. And first law of thermodynamics means total energy is constant. This is heat energy equals to internal energy plus external work done. Am I clear? Then what is some processes are there? What are those processes? That is isochoric process. Okay, isochoric process. What isochoric process says? dW equals to what you are getting? P dV. dW equals to P dV. Okay. If it is isochoric process, then you can write W equals to dW equals to P into dV. Isochoric means what? What is the meaning of isochoric process?
Volume constant.
Volume constant. Then what will happen? dV will be there or not? You tell me.
No. Zero.
Then in isochoric process, dV is 0. So no external work will be done. So external work done is equals to 0. Okay. What is isobaric process? Pressure constant. Then you can write dW. So then no work done in isochoric process. No work done in isochoric process. That is V Suman V equals to constant, dW equals to P into dV. Then if you write like this, what type of process it is I am going to discuss? Isobaric process. Isobaric process. The volume is variable. Then you can write V1 to Vf, and as P is constant, you can take out P, and then you can write V equals to Vf by Vf upper limit and Vi lower limit, and you can write like this: P into Vf minus Vi. This is work done in isobaric process. That means pressure is constant. Another process is there, isothermal process. What is the work done in isothermal process? Who can tell me? What is the work done in isothermal process?
When temperature is constant.
Yes, isothermal. That means PV equals to constant, that is K. Okay. Then you can write dW equals to P dV. dW equals to P dV. What it is? P into dV. Then it is isothermal process, na? Then isothermal process PV equals to nRT, na? If it is constant, then what you can write? You can write what? You can write P equals to nRT by what? V. P equals to nRT by V. Then what I can write? nRT dV by V. And if you take integration both the sides, what you will get? W equals to like this: N constant, R constant, T constant, and Vi to Vf. So what you can write? Log V e to the base V. What? Log e to the base V. This is Vf and this is Vi. So you can write here, what you can write? nRT. Then log e to the base V to the Vf to the base e minus log Vi to the base e, and this is the relation. So knowing these two, you can calculate work done in isothermal process. Another process is there, that is adiabatic process. What adiabatic process says? You see here what adiabatic process says. Here adiabatic process PV to the power gamma equals to constant. Okay, PV to the power gamma equals to constant. What we can write here? dW equals to what? P dV. What you can write here? Some constant, isn't it? So what you can write here? Some constant divided by V to the power gamma dV. What is gamma? Gamma is nothing but Cp by Cv. What is Cp? Cp means specific heat at constant pressure, and Cv means specific heat at constant volume. The ratio of these two is termed as gamma. Okay. Now you just do certain work like W equals to this, and if you calculate if it is Vi and if it is Vf, what you can do? You can take K as outside this integration sign. Okay, and what I can write? V to the power minus gamma plus 1 by gamma minus gamma plus 1, that is Vf, and this is Vi. Clear? Okay. Now what you can write? You are eligible to write K equals to K by 1 minus gamma equals to what? V f to the power gamma minus 1 minus V I to the power gamma minus 1. Okay, this is a relation. Okay, and here you have written like this. No? So what you can write? You can write Pi Vi to the power gamma equals to Pf Vf to the power gamma equals to constant. Okay, instead of writing Pi Vi to the power gamma equals to Pf Vf to the power gamma, and just you put the value to get the result. What I can do, you see here I can write like this. I am eligible to write like this. What you see, K V to the power Vf to the power gamma minus 1, Vf to the power gamma minus 1 minus K V I to the power gamma minus 1 divided by what? 1 minus gamma. What is the value? Pi, Pf, here you have to write Pf Vf to the power gamma. What you have to write? Instead of writing K, Pf Vf to the power gamma, what you can write? You can write Pf Vf to the power gamma into Vf to the power gamma minus 1 minus Pi Vi to the power gamma Vi to the power gamma minus 1 by what? 1 minus gamma. What is the result? What is the result? V gamma will cancel out. Okay? V gamma will cancel out. What you are getting here? V to the power minus 1 and Vi to the power minus 1. Okay? Then what you are getting? Pf Vf to the power minus 1 minus Pi Vi to the power minus 1 equal by 1 minus gamma. This is work done in adiabatic process. Now I have done all the relations regarding work done, because I have already told you, if you apply heat, then heat will manifest in two ways. One, it will change its internal energy, and residual amount of heat will increase its increase its volume, that is work done will be there, external work done. Now you see dq equals to du plus p dv. Am I clear? This is. Then you all know in H equals to mst. Is it known to you? In calorimetry you have studied it, na? So if you write here dq, then you may write m c p dt. Here it is T, because it is taken in absolute temperature. Okay, here we take temperature in absolute unit, in Kelvin unit. Then, and another you can write AM into Cp into dt. What is the difference between the two? Here Cp, here Cv. Here Cp and another one is Cv. Here is a specific heat at constant pressure, and is a specific heat at constant volume. The gas is such a substance which assumes two types of specific heat. One is at constant pressure and the other is at constant volume. You all know what is specific heat. The amount of heat it absorbs per unit mass. Okay, that is specific heat per unit time. Per 1 degree rise in temperature, that is specific heat, you know, because why? Here you see H by H by M into T equals to S. Then the amount of heat per unit mass per unit degree rise in temperature. That is specific heat. What is specific heat? The rise in temperature per unit mass per unit rise in temperature per unit mass. The rise in the developmental heat in per unit mass per unit degree rise in temperature. Heat is energy. So if you we should write in joule, then it will be J. It will be kg to the power minus 1 and Kelvin to the power minus 1. Okay, clear? Then what is, and you know dq. dq means the total heat. If the volume is expandable, if you are able to expand its volume, then dq is nothing but equals to what? dq is nothing but equals to dq is nothing but equals to m into cp into dt equals to, this is energy, na? Energy is also equals to m cv into dt plus this one, you know, pv equals to RT, then pdv equals to RT, you can write here. So it will be R into dt. So what you can write? Here it is m, here it is m. Then what? This is m. M means, that means m is the mass. So if the mass is unity, for unit mass, R will be unity, 1 mole. For 1 mole of gas, that will be 1, and this will also be 1. For 1 mole of gas, both the value will be 1, unity. This is 1 and this is also 1, this is RT. For n mole of gas, this will be n, this will be n, and also here it will be n. Okay, so you can write Cp minus Cv into dt equals to R into dt. And you all know dt not equals to 0. So Cp minus Cv equals to R. Or you can write another unit, R by J. If you write R by J, then joule per calorie, then it will be calorie, or otherwise it will be in joule. It will be in joule. Or if you write it in calorie, if you divide it with J, then it will be joule per calorie, and it is joule, that is calorie. Okay? So you can write, and you know the dimension of, on the left hand side, what is the dimension? Joule kg to the power, joule kg to the power minus 1 and k to the power minus 1. So it is unit is joule kg to the power minus 1 k to the power minus 1, and the right hand side also will be joule kg to the power minus 1 k to the power minus 1. So left hand side and right hand side unit will be identical. So the relation Cp minus Cv equals to R. So it is clear that Cp is always greater than Cv. Cp is always greater than Cv. So what is Cp and Cv? Constant, at constant volume specific heat, at constant pressure specific heat. So now I will tell you about the degrees of freedom and equipartition of energy. Degrees of freedom. Now I am closing. Okay. Now I want to tell you that these A and B are arbitrary constants. Dimension of A and B may be calculated. You can calculate. I suppose you are able to calculate the dimension of A and B. A and B. How you can calculate A and B? How you can calculate A and B? B means volume.
B is equal to B, so volume में जो dimension था
L cube, and here A by B square equals to P. that is Newton per meter square, or you can write like this, what, m n to the power what, n to the minus 2, okay, divided by ml n to the power minus 2 divided by l square, okay. This is the pressure, force divided by area, that means m n to the power minus 1 to the power minus 2, clear or not? Is there any mistake here? Okay, this is m l to the power minus 1, that is p, and here what you have to write, this is a, and here you have to multiply it with l cube. V means v square means v square means l to the power 6. Then what you can write, m l to the power 5 to the power minus 2. So it is easy. See, this question may also be asked in your exam. Okay, clear? Now I will go for degrees of freedom. What? Degrees of freedom. Degrees of freedom. Freedom. What is degrees of freedom? Freedom means your eligibility to move without being guided by anybody, without being controlled by anybody. And if a particle is able to move along a particular direction, x, y or z, it is free to move. Nobody will restrict its movement. So, if there are three directions along which it can move in a straight way, that is translational motion. Straight way motion means translational motion. So, let me to describe what that is noble gas. Okay, noble gas. They are actually like nun or monk. They have no partner with whom they can gossip. Okay, so noble gas is like helium, neon, etc. Okay, krypton, xenon, argon, all are noble gas. They
Radon.
remain alone. They like solitary place and to stay alone. Okay, like Anjali. Now, these all are monatomic gas. All are monoatomic gas. Monoatomic gas molecule. Okay. So what happens if a gas molecule is here, then it can move along x, y and z direction. Now I am going to teach you degrees of freedom. Degrees of freedom along which you can move free. And you see here there are three directions, one molecule. One molecule. And translational motion. Translational motion. Along which direction? X, Y and Z direction. And this is translational motion. And another type of motion is rotational.
Rotational motion.
Degrees of freedom should be there. Then you are not getting at all rotational degrees of freedom. Why? Why you are not getting rotational degrees of freedom? It is moving along two direction, but it can rotate even along its own axis. Then why you are not considering that?
Mass is very negligible.
No, not mass, but you tell like this. R is equals to 0.53 angstrom nearly. The molecular radius, dimension of a molecular, that is atomic radius, that is It is a monatomic. That means atom, there is no difference between atom and molecules. Okay. The person who is monk or nun, there is no difference. A human being after all. If there is any female, then there is a question of male. Okay. If the female is there, then you should not say male. Okay. Only one. Only one. Then what? It is having a dimension like r is its radius. And you all know 1 angstrom is equals to 10 to the power minus 8 centimeter is equals to 10 to the power minus 10 meter. Am I clear? Clear? Then what you can do? You are viewing here tau equals to r cross f. Isn't it? Tau equals to r cross f. If you write like this, Rf sin theta or something like that, or if you write, if the angle is like this 90 degree, then you can write Rf. R is small and F means R into F means m into a. Force equals to mass into acceleration, and here R equals to m into a into r into alpha. Then what you are getting? M into r square into alpha, and this is nothing but equals to I into alpha. Okay, clear? Dimension is very, very small. R is small. You see, I am giving here R equals to 53 into 10 to the power minus 2 into 10 to the power minus 10 meter. That means very small, 10 to the power minus 12 meter. And you take the square of this, you will get a result here like this one square, and this is 10 to the minus 24 meter. So think it, so small it is. So small it is. 10 to the minus 24. Are you able to realize the dimension is so small? So you can ignore. You can write r square tends to 0 or I tends to 0. If I tends to 0, tau equal to 0, there is no torque. As there is no torque, it is not rotated. So there is a possibility so far as the rotation is concerned, but it is not rotating because there is no tau is acting on it. Am I clear? So I suppose you have learned the best way. Mostly people do not know this. They will just memorize the fact and they will tell you this is the reason, this is you have to memorize, nothing else. We don't know. This is a small molecule cannot rotate. This is not the answer. Okay, I am clear. So, what is degrees of freedom? Then number of degrees of freedom in case of monatomic gas is what? F equals to how much? 3. How much? 3. Okay. Then Cp I have told you na. Cp is greater than Cv.
Yes.
Cp is greater than Cv. The Cv equals to what we can write F by 2 into R. What you can write? F by 2 into R. And Cp equals to F by 2 plus 1 into R. 1 into R. Okay? 1 into R. And just to take the difference, Cp minus Cv will be equals to R. R is gas constant. R is gas constant. Who can tell me the unit of R? What should be the unit of R and the value of R? Who can tell me?
8.314.
Yes, you tell me. Who can tell? Tell me. you can 8.314.
Calorie.
No, madam, no.
Calorie.
What is R equals to 8.314 joule per. Why? Mole to the power minus 1 and Kelvin to the power.
Minus
Why? Take a note, you write. Mole, what is the unit? Mole to the power minus 1, K to the power minus 1. Why it is mole to the power minus 1? From where you have got this? Where you have got it? No, not that. I will tell you how you can elicit the result. You can find the result. You see here, PV equals to nRT, na? Am I clear? Just to try to realize, everything is very easy if you try to understand. And what R equals to PV divided by NT. Am I clear? PV is work done, that is in joule, and N is mole, that is mole, T is Kelvin, that is Kelvin, and the value is 8.314. So value is this and unit is this. So mole to the power minus 1, K to the power. Then what do you think? Is it possible for you to remember all the facts always? Somebody told you that is why you will remember. In this way you can remember. The basic thing is this. In this way you can remember. Is it Greek to you? It is typical for you to understand? No. Then this is actually the value of R. So what is degrees of freedom? In case of monatomic gas, 3. And Cp minus Cv, what is Cv? This is Cv and this is Cp. Okay? So many questions are asked from this chapter on the basis of this idea. The next time I will solve a good number of problems. Today I will solve 1 or 2 such problems. Okay? Because of shortage of time. Now you see degrees of freedom for diatomic gas. Diatomic molecule. What? Diatomic. Which molecules are diatomic? O2, H2, etc. So many. Diatomic. Clear? Then what should be its degrees of freedom, my dear?
5.
Why? You have just ratta marke memorized here. Ratta mark. Why 2 rotational motion? Why not 3?
Because
You have just memorized it. Are you able to describe on the board? Not at all, I am sure. Not that, don't try to cram. I told the person who taught you that it is not a way. You have to teach the basic thing so that you can remember facts. Okay? I will tell you how you will be happy enough once it is understood. Otherwise you will remember 2 is there, 3 is there, no is there, only 2. Why 2? Why not 3?
5 is there.
There is 3 translational. It is easy, na? There is standard protocol is that 3 axis. X, Y, Z. They are free to move. 3 degrees of freedom. Translational. What it is? Translational motion. Or translational degrees of freedom. Or maybe translational motion. And here there are 2 particles, na? 2 particles, 2 atoms will give you one. What it will give you? One molecule.
Yes.
So you are telling what should be its rotational
Motion.
degrees of freedom. Degrees of freedom or rotational motion. How many? The if it has no dimension, it's very small, but the distance between two atoms is not ignorable, no?
Yes.
So if you keep it on the x-axis, suppose if you are keeping it on the x-axis, okay, you just feel, try to feel. If you want to heal yourself, you try to feel what you are getting. You see, here this is one axis, that is from this to that, okay? It's the axis along which it is rotating. Along which it is, two molecules are there, that is separated at distance, but distance is not negligible. That's 1 degree of freedom you are getting in this way. In this way, here two particles. This is actually how it is moving in this way. Along perpendicular to this or in this way. Okay. And the other, it is along another axis. It can move in this way. In this way. That is in this way. The distance between the two molecules is not ignorable. But so far as the x-axis is concerned, how it will move? They are on the same line. They are on the same line. They can only transfect, move along an axis, cannot rotate. When it will rotate? When the two forces are in opposite direction, then moment will take place and it will rotate. And if both the forces act on the same line, then no such torque will be there. So along x-axis it is not possible. So only you are getting 2 degrees of freedom. And this is rotational, this is translational, that is 2. Total degrees of freedom is F equals to 3 plus 2 equals to 5. Not only this x-axis, you can assume this as z-axis, these as x-axis, and these as y-axis. No problem is there. Here along z-axis, it is 0. Along z and along y-axis, it is having certain value. Try to understand the basic thing. Otherwise, you won't get happiness so far as your subject is concerned. I am sure a good number of questions may be asked in this year based on these ideas. 3, 5, that is for monatomic gas, diatomic, it is degrees of freedom
5.
Degrees of freedom 5. Monatomic
3.
monatomic,
Gas.
it is 3. Degree of, and now another case will arise, that is polyatomic. That is, polyatomic means when Brahma created us, foremost he created some gods. Thereafter, human being. Also he applied brain. Okay? Thereafter, demon. Go and do what you like. Isn't it? Actually, there are 3 types of animal. God is also one type of animal. We are also one type, and demon is another. Isn't it? So, God actually wanted to create 2 types of animals in a proper fashion. And the next animal is identical. All are same. Demon. Isn't it? Like mule or something like that. Those who kill people, those who do certain bad work with male or female, they are demon. Isn't it? So, this is polyatomic gas. But in case of polyatomic or triatomic gas, more or less identical. there is no difference between polyatomic and diatomic. What and I can say? The third one is dem1. That means it may be third one, fourth one, fifth one, sixth one, all are in the same plane. We all are on the same boat, brother. The demon can say, we all are on the same boat, brother. Now you see, there are three dimensions. That is, translation motion is Fr equals to 3. And here rotational motion is there. Na? Here you see, A show 2. There are two cases. One is linear and the other is non-linear. In case of linear, that is degrees of freedom equals to 5. And in case of non-linear, degrees of freedom equals to 3, 6. 3 plus 3, 6. So, if you consider a non-linear like this, angle is there, then it can move in this way, in the three-dimensional motion will be there. Okay? Or on the, in case of carbon dioxide, if they are on the same line, then it is linear. Only degrees of freedom is 5. Why? Here rotational, here it is translational, and this rotational is 3. Non-linear case. Non-linear cases. And total, if equals to 6. So in case of one dimensional, 1 monatomic, 3, diatomic, 5, triatomic, 6 or 5. 6 or 5. For non-linear, it is 6. For linear, it is 5. For some demons are also like that of human being or like that of God. Not that God, but human being. That is 5. Okay? And some others are not. Those who are straight, they are like human being. Some demon. They actually pretend to be a human being.
But actually are not.
What? Maybe. But this is actually a relation. I mean, clear or not? So I suppose you have all understood. You all have understood degrees of freedom. Clear? And how I use degrees of freedom, I have already told you this. Okay. Now I will tell you partition of equipartition of energy. Okay? Equipartition of energy. What is the meaning of equipartition of energy? I suppose you have all understood this one. Okay? What? What you understood? Degrees of freedom. Now I will tell you what it is. What? Equipartition of equipartition of energy. Equipartition of energy. Okay. What it is? Actually, we considered that energy is distributed equally in all directions. And if you take three directions like x, y and z, the total energy will be distributed among three directions in some way. In each direction, equipartition of energy is equals to half kT. What K is? K equals to
Boltzmann constant.
Boltzmann constant. Would you tell me what is K? Nk equals to R. You remember it in this way. And K is nothing but equals to R by N. What N is? N is equals to 6.022 or 23 into 10 to the power
23.
minus
23.
23 or plus?
Plus 23.
Plus 23.
Yes.
Why not minus? Number cannot be like negative. Then fraction. Number, na? That is why 23. This is Avogadro's number. And This one is Avogadro's number, this one is Boltzmann constant, this one is R. R means universal gas constant. Now you tell me, what is the meaning of half kT? Tell me. Right. Foremost you write. No. What is the meaning of half kT? Like write equipartition of energy along a specific direction. You write equipartition of energy along a specific direction. Equipartition of energy along a specific direction. You write. What do you write? Equipartition of energy along a specific direction. Along a specific direction. And total energy equipartition, that is equipartition of energy along a specific direction. For which one? This is applicable for equipartition of energy for a particular direction, for a particular molecule. Right note. For a particular molecule, the energy is half kT. Energy is half kT. Energy is half kT. Molecule. Then each molecule is having how many degrees of freedom? How many degrees of freedom? 3 or 8, like that. You should not say 3 or 4 or you do not know what the gas it is. You are telling 3 or 4, no. 8. Then what should be the energy? Degrees of freedom. Each degrees of freedom is having energy, na? In each direction means each degree of freedom. What? F into what? F into K into T. Take a note. F into K into T. F into K into T. F into K into T by 2. Okay? F into K into T by 2. 1 mole of such gas. 1 mole means in number. 1 mole means in number. In number, 1 mole, each molecule that is. But 1 mole means N into F into K into T by 2. That is 1 mole contains N number. That is N total energy. Okay? And in F by 2. K means what? R by N. Isn't it? R by N and into T. What you are writing? You can cancel it. F by 2 into RT. So, this is the total energy for 1 mole of gas. If it is degrees of freedom, you can calculate. For monatomic, this question will be asked. Very easy, na? Question is very easy. Almost what you have to know, you have to understand the basic thing. What is the basic thing? F by 2 into R into T. And you all know the value of R. I have already told you. What is the R? You tell me. What is R? You tell me.
Universal gas constant.
Yes. Then you can write it. And it is for in 1 mole. And if I write N mole of such gases, only you will write N into F by 2 into R into T for N mole of gases, for
N mole of gases.
N mole of gases. Am I clear? So for 1 molecule, 1 degree of freedom, it is half kT. For 1 molecule, F degrees of freedom, F by 2, that is for N molecules, that is 1 mole, it is for N moles, this one. There are 4 relations. All type of question will be asked. For one mole, for one molecule, for 1 degrees of freedom, they may ask you a question. You just read the question, then you answer. Okay? For one molecule, 8 degrees of freedom, they may ask you a question. For 1 mole of gases, total energy they may ask you. For n moles of gases, there are 4 relations. Okay? 1, 2, 3, and 4. Okay? So this is all about your degrees of freedom and first law of thermodynamics. I suppose you have understood it better than me. Okay? Have you understood all of you have understood?
Yes, sir.
Okay. Don't pretend that you have understood. Always try. It is so easy so as to drink a glass of water. Only you are not in a position to drink water. Okay. You have no thirst. That is why I cannot help you. I can help you if you are having thirst. Okay. Then you will just absorb all the water that I will deliver, but so far I have delivered to you. Okay? Then I will discuss one problem. I will discuss one problem. I am not getting problem, that is a great problem for me.
Yes, sir.
Now, write a polyatomic gas. A polyatomic gas. This question was asked in the year 2009 NEET. 2009 NEET. A polyatomic gas. A polyatomic gas with n degrees of freedom. With or in medical term you can write like this. This is also with. With what? With yes. With n degrees of freedom. With n degrees of freedom. What happens with n degrees of freedom? Has a mean energy per molecule. Has a mean energy per molecule. What? Mean energy per molecule is given by, there are four options. There are 4 molecule is given by, you just try to answer. Given by 1, it is nkt by n, nkt by capital N, 2 option second, nkt by 2n, nkt by 2n, the third one, that is equals to nkt by 2, nkt by 2, and the fourth one is 3 kt by 2. 3 kt by 2. Who can answer the question? This is very easy. I have already taught this to you. And this was a question asked in 2009 NEET. And also, I think expected in your year also. 2025 or 2026. Okay? Tell me. What will be the answer? N degrees of freedom. You just follow. For, just to tell me, if you are able to understand, you tell me the option.
Option 3.
Option 4.
Option? Who are in favor of option 3? Who are in favor? Right. Who are in favor of option 3? that is a good girl, and another Shukriti, and another no one. See, and you tell me. Shukriti has informed. Shukriti has told me that this is option 3, and other Duskritis are not telling anything.
Option 4.
Option 4.
Option 4. All are Duskritis or Shukritis, let it be seen. Then, option, why option 4? You are thinking it is option 4, that is option 4.
No, sir.
Then how you have calculated? My dear daughter, how you have calculated it?
Sir, option 3. Option 3.
Now you are trying to reside on the same boat. You are coming on the boat of Shukriti. Once upon a time you are Duskriti and I am Shukriti. No. You tell me which one? This one, this one, this one, this one. Which one? Option 4.
And I'm telling option 2.
A polyatomic gas. What about the gas B? It is immaterial to us. A is the degrees of freedom, it is immaterial for us. And you see here, this is K. This is K, this is K. What K means? What is the meaning? This is N. What it is? With N, degrees of freedom. This is N is the degrees of freedom. You have already told that N instead of N, it is because N. F, you wrote F.
8 by 20
Isn't it? I told you half kT, na? Half kT. Okay? Have I not told you this? Then for F degrees of freedom, that is F kT by 2. If it is N, then it is N kT by 2.
Yes.
Then Shukriti, give a big hand for Shukriti, please. Yes, he has done excellent. Large applause should be Shukriti claims because you all failed to answer.
Thank you, guys. Thank you, guys.
Okay, then today I am going to close this discussion here. Tomorrow I will start from here. I will give you a what can I say, problem sheet based on my discussions today. I suppose you all will conduct practice and will come with flying colors in the year 2025. Thank you.